Hello all. So in today's class we are going to discuss about deterministic finite automata. In short we are going to call this DFA. So I have taken one example to define exactly what the deterministic finite automata is. So let us see, for example, the DFA is consists of certain diagram. So in this diagram there are three concentric circles as you can see, which are colored blue. So these are called as states. The circles are called as states. So how many states we are having? We are having three states, Q0, Q1 and Q2. So we can define this DFA with the grammar G is equal to VTPS, which is a quadruple. So what is V? V is a set of states. So in this given example, what are the states? Q0, Q1 and Q2. Next, T is the set of input symbols. So which we tell or represent in this form. So both are same. So in this particular grammar, we are going to represent this T. T stands for terminals. So terminals, what are the input symbols we are passing in this particular given above diagram? 1, then 0, 0, 1, 0 or 1. So which is a combination of 0 or 1. So the terminals are going to be represented with 0 and 1. So the terminal is a set of input symbols. Now what are P? P is nothing but it is a set of productions. Productions means we are going to represent the productions in terms of A producing 0, B or 1, where A and B are the variables and 0 and 1 are called as the terminals. Next is a S, which is represent start state. So in our given diagram, Q0 is the start state. Why the Q0 is called as start state? Is the machine will start parsing the input string from the state Q0. So how we are going to determine which state is start state? The start state which is having an arrow before which is not having any particular state. So before this arrow we are not having any state here. So because of that Q0 is called as the start state. Then Q1 is called as the intermediate state as it is between the start state and the final state. Hence Q1 is called as the intermediate state, and there can be multiple intermediate states also, depends upon the situation or the problem. Next is Q2. Q2 is the final state. So the final state is always represented with the two concentric circles. So as we can see in the given diagram, Q0 and Q1 are having only one concentric circle, but Q2 is having two concentric circles. So where all the two concentric circles will come, they all are called as the final states. Or whenever we are going to define a DFA for given language, then for the final state we are going to concentrate with the two circles. So what are the input symbols? So input symbols are 1, 0, 0, 1, 0 or 1. Depends upon the language, we are going to give the transitions for from one state to another state. Also here in the given example, the state or the machine will move from the Q0 state to the Q1 state by accepting the 0 input symbol. Then the machine can further move from Q1 state to Q2 state by accepting the 1 input symbol. Now the machine can also, we can see here, there are loops. We can see here loops. So these are called as self loops. So even for Q0 also we are having self loop, for the Q1 we are having self loop, for the Q2 also we are having self loop, and even these loops are going to carry one input symbol. So for the Q0 there is an input symbol 1 for its self loop. Then for the Q1, 0 is the input symbol for its self loop. Then for the Q2, 0 and 1 both are the as the input symbol for the for its self loop. Here the self loop can be treated as the optional one. So if we want, we can go with this loop, or else directly the machine can move from the state Q0 to Q1. If it wants, if the given input string is needed to take this one, then machine will go with this particular loop and it will pass with one value. Then it will go from Q0 to Q1 and it will accept 0. Then again it may go with this loop or may not. If it go with this loop from the state Q0, then 0 will be accepted as the input string. Then the machine will move from Q1 to Q0 by accepting 1 as the input symbol. Then the ultimate, the taken individual symbols will obtain the complete string. So that string will be accepted if machine moves from start state to final state. If the machine moves from start state to the final state. Final state. So if the machine moves from start state to the final state by passing through the intermediate states, then that particular string will be accepted by the machine. So there are important notes with respect to deterministic finite automata, also the finite automata. They are in individual DFA, there should be only one start state. There should be only one start state. Then there can be multiple final states. In our given example, here we have taken only one final state, but depends upon the different languages as well as the condition, the DFA may change. And this diagram is called as transition diagram. This diagram is called as transition diagram. In the transition diagram, we can have only one start state and we can have multiple final states. And it is mandatory in this DFA, that is, there should be only one transition for each input symbol from each state. So we can observe from the given diagram that there is only, see, we are having the set of input symbols with summation is equal to 0 comma 1. So the possible input strings which the machine or the DFA can accept is only 0 or 1. So from each state, so let us say from the state Q0, we should have only one transition for the 0 input symbol. So hence we are having only one transition from state Q0 to Q1 for the input symbol 0. Also for the input symbol 1, we are having one self loop. We are having only self loop from the state Q0 to the state Q0 only. So for the input symbol 1. So from the state this Q0, we are having only one transition for 0 and only one transition for 1. So again in the same way, for the state Q1, for the state Q1, we are having only one transition for the input symbol 1 and there is only one transition for the input symbol 0. So we cannot see there are multiple transitions from the state Q1 for the 1 input symbol and for the 0 input symbol. So only there are two transitions from the each state. So from the Q1, this is one transition and self loop is also one transition, and this transition is for 0 and this self loop is for 1. So only one individual transitions are there for each input symbol. So again for the Q2 also there is only one self loop for both 0 and 1 input symbols. So because of this, this machine is called as deterministic finite automata. So now we'll see about how we are going to see the transitions for these individual input symbols from individual state. So as there are few steps. So one is represented with current state, then the input symbol which it is taking and to which state it is moving. So that next state it is called as next state, and that can be represented with the transition. So here there is a certain pattern to be followed to represent this transition. So that is the delta symbol is representing to transition to indicate the transition. Now, in the delta, there are current state. Okay, first parameter to be passed for this delta function is current state, then the input symbol, then it is leading to the next state. Okay, for this delta function, there is first parameter is current state, then second parameter is input symbol. So from which state, by accepting what input symbol, to where or to which state it is moving. So that can be represented in this transition function. So this is a transition table. This is the transition table which we are representing for the given transition diagram. Okay, so let us see how many states we are having in the given diagram. There are three states. One is Q0, then Q1, then Q2. So I have, and how many input symbols we are passing? Only two, that is 0 and 1. So I am going to represent for each state, I am going to give each input symbol and I am going to write to where it is moving further. Okay. So let us see, observe carefully. Q0 is the start state. So I am writing Q0 here, and this Q0 can be represented with an arrow. Okay. So from the state Q0, after accepting 0 as the input symbol, where it is moving. So observe the diagram here. From the state Q0, after accepting 0 input symbol, it is moving to Q1 state, right? So hence I am writing Q1 as the next state. So now, from the state Q0 for the input symbol 1. So, let us see the transition here. From the state Q0, the transition for the input symbol 1 is self loop. Self loop is nothing but the machine is moving from the state Q0 to the Q0 only. Means it is remaining in the same state after accepting 1 as the input symbol. So, hence we are going to represent this as from the state Q1, Q0 by accepting 1 as the input symbol, the machine is moving in the or it is remaining in the same state Q0. Okay. So now next state is Q1. From the state Q1 for the input symbol 0. Now within the diagram from the state Q1 for the input symbol 0, we are having a self loop. So it is remaining in the same state only. It is not moving to any other state. So hence we are representing it like this. From the state Q1 after accepting 0 input symbol, it is having self loop or it is remaining in the same state. So it will remain in the same state Q1 only. Then from the state Q1 again there is a transition for one input symbol and it is moving from state Q1 to Q2. Hence from the state Q1 for accepting 1 as the input symbol, it is moving to the state Q2. Okay, so this is represented like this. Then we'll come to the final state, that is Q2. And this from this Q2 state, there is a self loop for both 0 and 1. So the machine will stay in the Q2 only after accepting 0 or 1. Okay. So hence because of that, from the state Q2 for 0 as the input symbol, it is remaining in the Q2 state only. In the same manner, from the state Q2 for input symbol 1, it is again remaining in the Q2 state only. Now, within the transition diagram, the start state will be represented with the arrow mark. Then the final state will be represented with the one concentric circle. So this is how we can represent it. Now comes is how to represent this transition with the delta function. So I have represented. So our formula currently is for the delta function. First is current state, then input symbol which we are passing, then the next state where it is moving after accepting this input symbol. Okay. So in the same pattern we have represented here. See, the current state is Q naught. The input symbol it is taking is 0 and it is moving to the state Q1. So I have represented like this. So same, the current state is Q naught, then input symbol is 1, 1, then it is moving to the state Q naught or it is remaining in the state Q naught only. So that is represented here. So in the same manner, I have represented the transition for all the above possibilities. So now we'll see exact definition of DFA. So what is DFA? Actually, a DFA is a phi-tuple or quantuple machine. Okay. So what is this machine is with? The machine is with the 5-tuple values where the Q is non-empty finite set of states. So Q is for states. Okay. Next, the summation. Summation is for non-empty finite set of input alphabets. Then delta. Delta is for transition function which is mapping from Q, that is states, for each input symbol it is moving to another state or remaining in the same state. So this is can be for Q into summation is equal to Q. Then Q naught. Q naught is which belongs to the set Q only, which belongs to the set Q and it is representing for the start state. Then A. A is the last tuple out of the 5-tuple and which is also the subset of Q. Capital Q is nothing but finite set of states. Among the given states only, Q naught will be defined. One among the given states only, one will be the start state, another one will be the final state. And it depends upon the language or the problem. The start state can be the final state also, but depends upon the individual language, not always. Okay. So A is the subset of Q, which is a set of accepting or final state. So even the final state can be called as accepting state. So now we'll define the definition for the given DFA. So now what we have discussed just now, the machine is a quantuple, right? The machine is a quantuple. So first one is capital Q, which is a set of states. So here our states are Q0, Q1 and Q2 and I have listed in the list which represents for the set of states. Then what are the input symbols which are passing here are 0, 1, 1, 0, 0 or 1. So all are with the combinations of 0 and 1. So this can be represented in this. So that is the second tuple. Then the third tuple is delta. Delta is for transition. So as we have discussed how we are going to represent the transition table also. And this table is called as transition table. So in the transition table, we are going to have current state, input symbol, next state and the transition representation. And this is the standard function which can be represented for the transition. Then this is this complete table is for this delta tuple. Okay, that is the third tuple. Next comes the Q naught. So Q naught is the start state here. So that start state is represented here. So in our diagram, Q naught is the start state. So as in the set, Q naught will come. Then A stands for accepting state. So which is the accepting state in the given DFA? Q naught is the accepting state. Why? Because it is with the two concentric circles. So hence A is equal to set of Q2. In our given DFA, or in this particular given DFA, there is only one final state. So because of that, we are giving only Q2 as the final state. So this is